Hello, everybody. We are going to start on chapter 11 now, which is evolution. And we've talked and alluded to evolution a fair amount this semester, even just when we were discussing agriculture and genetically modified organisms and traditional ways of modifying crops by selectively breeding them versus genetically modifying them. So now we're going to get deeper into evolution and really understand what is evolution, what is natural selection, what are other ways that populations can change. So we are going to get started on that. Let me pull up the slides for you. All right, so here we've got a picture of a Galapagos tortoise, and we're going to be talking about the Galapagos a fair amount, just because this is one of the places that Charles Darwin visited on his voyage, which helped him formulate his theory of evolution. So the things that we're going to be discussing are the fact that, first of all, evolution is ongoing. It's not something that happened in the past and stopped. Um, it's happening now. We've seen that with the mutations of COVID and the Delta variant. That's the virus evolving. Um, we're going to talk about the evolution of the theory of evolution. So how did Darwin, who was one of the people who came up with a theory, um, how did he think of that? What were the people and um, the the surroundings that influenced him? We'll talk about the four mechanisms of evolution. So natural selection, everyone's heard of, but that's just one. We will talk in depth about natural selection, and then we're also going to talk about the preponderance of evidence. So evolution is called a theory, and as you recall, a theory in science is not just a guess or a wild idea. A theory is a hypothesis that has been supported over and over and over again through multiple lines of research. So there is very, very, very strong evidence for evolution. Okay, so the first thing we're going to talk about is what is evolution? And it is the change in the genetic makeup of a population over time. So I really want to stress this here. Um, Population. That's a really, really important word. Populations evolve. Individuals don't. Because it's a change in the genes. Your genes are the genes you were born with, and they are the genes you will die with. They don't change, but the population as a whole can change. It can become more redheaded or more brunette, right? The frequency of these genes can change. That's evolution. And so it's really important to understand that this is happening at the population level, okay, not the individual level. Individuals do not evolve. Population, okay? So now we're going to kind of have a historical journey here. All of the different ideas that people had over time on how organisms could change or whether they changed at all. And then we'll get into how evolution works. So there were a lot of ideas before Darwin, and many of them were not evolutionary ideas. So most people for 1,000 years thought that life was really static and there was a type species, right? Like a squirrel looks like this, and all squirrels should basically look the same and not really deviate. So that was the thought, all the way from Aristotle up to Darwin. Um, but things started to change a little bit in the 1700s. So Buffon, who we've got here on the far left, um, he was the first person to say that the Earth was probably older than they believed. Um, at the time, they thought the Earth was about 5,000 years old. And he said, well, actually, I think it's about 75,000. So, I mean, he was off by quite a bit, but 75,000 is still much older than 5,000. So he's the first one who thought that and was willing to at least publicly say it. George Cuvier and we're going to talk about all these people in a little more detail, um, really got into fossils and was the first person to suggest that extinction had occurred. Lamarck, he actually did come up with a theory of evolution. So Darwin was not the first person to come up with this theory of evolution. Um, Lamarck did think that living things could change over time, but his methodology of how that happened was wrong. So Lamarckian answers in class will not be marked as correct. And then we get to Charles Lyell, who was actually a peer of Darwin's, and he thought, and he was kind of the father of modern geology, and he published a book that was very influential at the time, and he mostly talked about how the Earth could change over time, but this impacted Darwin's thinking. So let's get into these guys a little bit more, um, starting with Cuvier. Um, so he lived in the 1700s, and people had found fossils, um, but at the time, they mostly thought that the fossils that people had been digging up and finding were just dead things that still exist, on Earth. So they just thought they were finding old skeletons. Cuvier was the first person that said, you know what, some of these fossils are really much too different from things that we see walking around. They have to be from animals that no longer exist. So we have here um, a mammoth um, jaw, and at the bottom here we have an elephant jaw, and they're pretty different from one another. And he said, a mammoth is pretty big. This jaw is really big. There's no way these are wandering around in the like forest and we haven't seen them, right? They're clearly just no longer exist. And he was the first person that theorized that organisms may go extinct. We do not live in the same earth as the past. Um, Lamarck thought that, as we said, he was the first one to come up with a theory of evolution. He thought that traits could change over time, but he thought that individuals could evolve and that traits changed whether you use them or not. But if you gained a trait, that you could pass that on to your offspring. Obviously, none of them understood genetics at the time, but his classic example was with giraffes. So he said that giraffes, stretch and stretch and stretch their necks um, so that they can reach the higher leaves. And that's how their necks get long, right? Each individual stretches a little bit, gets a little longer, and then they pass that long neck on to their offspring. And, this guy died at the bottom here because he didn't try to stretch his neck, right? So that over time, everybody really working hard to stretch your neck could result in evolution. This is wrong, first of all, because if you lift weights, you're not going to have a baby with big muscles. If you get a tattoo, you are not going to have a baby with a tattoo, right? Acquired traits are not inherited. You can only pass on things that are in your genes, right? That are in your germline, your gametes. Um, Also, individuals can't try to evolve, right? You can't work hard to stretch your neck so that you can evolve. You are stuck with your genes and those don't change. You can learn new things, but that's not evolution. So learning isn't evolution, trying isn't evolution. Evolution is in your genes. So now we get to Lyell. He had a really big influence on Darwin. He wrote this book, The Principles of Geology, and his idea was that small changes over time, like erosion, right, water just flowing through an area, could eventually erode it and accumulate. Like small changes accumulate, and they have this additive effect to form caverns and canyons, right, and completely change the geology of things. Um, and this really influenced Darwin's ideas because he said, well, if small changes can add up over time on, with this dirt and rocks, maybe those small changes could add up over time in living organisms as well. Lyell did not agree with him on this. So it's not that Lyell kind of fed him this information. But Darwin took Lyell's ideas and kind of made this leap with it. And I think we will stop here and pick up with the next lecture on the more about Darwin and his influences.